DAX or data analysis expression is a powerful language that allows you to create custom calculations and measures in Power BI. It's essential for any Power BI developer or data analyst to know how to use DAX efficiently. Now these are the main categories of DAX functions that we will cover in this video. After watching this video, in case you feel that I missed any particular DAX, then do let me know in the comment section and I will be happy to look into that and take that up in the next video. This video is designed to be a go-to guide for anyone who is preparing for a Power BI interview, learning DAX from scratch, or just needs a refresher. This will provide you a clear and concise explanation of each function as well as examples of how to use them in real-world scenarios. So before we start, just a quick disclaimer. We'll be using Power BI to cover DAX related topics, but the concepts are the same if you would like to use Excel, Power Pivots or Power Query. Alright, so let's just get started. So today's video, I have divided it into several topics and each of the topics are individually important to understand. That's why I'm going to go each one of them in detail today. Okay, we're talking about DAX today and an introduction to DAX. So it's important to first understand how do we structure it. So similar to how we write Excel function, DAX also has predefined functions and operators which are clubbed together or used individually to create your final DAX formula. Now, this is an example of DAX function which sums two columns separately and then divide them to get the final result. Okay. Now, here we have used the sum function, which is a predefined function within DAX, similar to Excel, with the division operator to get the final result. Okay. Now, since we're talking about operators, it's important to know the list of operators that are used in DAX. So here is a list of operators that are used in DAX. On a high level, we have arithmetic operators, comparison operators, text operators, and logical operators. So now, where can we use DAX functions? So there are two areas or ways how we can use our DAX formulas. First one is inside a calculated column and the second one is inside a calculated measure, and we'll understand each of them separately. Okay. When you want your calculations to be done on a row level basis, then we enter DAX into a calculated column. Now let me explain this with an example. To understand this example, we'll first import the dataset that we're going to use today. The links will be in the description in case you want to follow along. So the requirement here is we need to create a new column which will show the revenue for each row item in the data using the price USD column and the sales column. So in this case, since we need to calculate the revenue for each row separately and store it inside a table physically, we will create a calculated column. Now usually while creating a calculated column, I prefer creating it from the data view because it gives us a visual preview of the data. However, there are other ways as well which are as follows. So the first method is simply to go to the report view, go to the modeling tab and click on new column. The second option is to go to the table where you want to create your new column in the field section and click on this three dot icon and click on new column. Okay. And the third method, which I usually prefer, is to go to the data view and right click anywhere on the table where you want to create the column and click on new column. Okay. So I'm going to use my preferred method here. And once you done that, once you clicked on new column, just enter this formula here. So I'm going to name this formula instead of column. I'm going to name this as revenue and I'm going to use price and sales column to get my final revenue. I'm going to just simply write price, and Power BI has an IntelliSense feature. So you can just select it from here. You can either click it here or press tab. So I'm going to just click here and price multiplied by sales. Okay. So I'm going to use this sales column here. So the way DAX is formed is, if you notice, it gives you the table name and then the column name. That's how DAX is structured. This is helpful because if the same column name exists in more than one table, then it will be easy for you to identify which column you want to refer. Once you have entered the formula, press enter or click on this tick icon here and you have successfully created your first calculated column. Okay. Now, coming to the second place where we can use a DAX is calculated measures. So when you want to do a calculation on an aggregated level and don't particularly want to store information on row level basis, then that is when you want to use calculated measures. Now, in comparison to calculated columns, measures don't create physical values in your table. Hence, do not increase the file size. So that is an important point to note. Okay. Now, coming to measures, I'll explain it with an example. Let's say the pizza shop ran a 15% discount on each pizza. So what we need to do is we need to calculate the final revenue for all pizzas sold using the price USD column, sales column, and the discount percentage. Now, in this case, obviously we'll be using a calculated measure because we don't particularly want to store the information in a table and instead want to calculate the aggregated value. Now, measures will not be visible anywhere on the data view. Okay, so hence I prefer to use measures or create measures obviously in the report view. Because since measures are not stored physically on a table, you would not be able to see the measures physically in anywhere on the table unless you drag that measure into a chart or a matrix kind of a visualization. Okay, so to create a measure, what we need to do is I come to the report view here and click on the three dots icon here and click on new measure. And to fulfill our requirement, what we need to do is, first of all, we'll give a name. I'm going to use ref discounted here. Okay. And one main difference between a calculated column and a measure is while using a calculated column, you don't have to specifically run or apply an aggregation function with your column name. But with your measure, an aggregation function is mandatory. You need to encapsulate your column name with a aggregation function. And my measure has been created. Now the final topic for today is implicit measure versus explicit measure. Okay. Now this is just a concept that you should keep in mind. By default, when you drag a column into the report layout, Power BI automatically creates an aggregation measure, which is known as implicit measure. Okay. You might not have realized this, but let's say I create a chart here. So when I dragged sales and pizza name onto this chart, in the x-axis, you must have noticed that it automatically aggregated my sales so that my output has a grouped effect on it. Okay, so it applied a sum function. I can also apply an average function, minimum function, and all those functions. So these are predefined functions which Power BI has, and when you drag a column onto the report layout or the visualization pane, it automatically applies that implicit measure onto your metric. Now, on the other hand, explicit measure are the measure which we create by entering a custom formula in the formula bar, like we did earlier while creating the revenue and rev discounted columns. Now, both type of measures serve their own purpose, but explicit measures are much more flexible and help in building complex logics for custom analysis on your metrics and KPIs. So, continuing our journey into DAX functions, we're going to see today how we can create a simple table by writing a DAX formula. Yeah, you heard me right. We can create a table using DAX. And specifically, we're going to create a table for calendar, a single column table, which will have calendar dates in it. I'm going to use the same data that we used last time so that it's easier to understand and relate what we're doing. So in order to create a new table from DAX, first step that we need to do is we need to go to the modeling tab. Okay, and inside the modeling tab, you will see a button called new table. All right, so click on this button called new table. Instantly, you will see a formula bar where we will be entering our DAX formula. Okay, so we're going to cover two basic DAX functions today. First one is calendar and second one is CalendarAuto. Okay, so I'm going to start with calendar. So what calendar does is it creates a table for you from a starting point and an end point of date that you give to the DAX function. So let's say the starting point for my DAX is 1st of January 2022 and the end point is 28th of Feb 2022. Okay. and close. So I've given it a starting point and an end point. All right. And I press enter. The moment I press enter, it created a table here. Okay. You can rename the table as per your liking. But if I go to the data view, as you see, it has created a table for me. I'm going to quickly format this into a date format instead of a date time format. Okay. And as you see, it created a list of dates for me starting from 1st of January to 2022 till 28th Feb 2022. Okay. Now, if you remember, couple of videos back, we learned how to create rolling dates using mQuery. The difference between that approach and this approach is that in that approach, we had a specific parameter for defining duration. Okay. So, I mean, suppose you want the dates to have, 1 day duration or 2 day duration or 3 days duration, you can use that approach. But if you do not want that and just want a simple start date and end date and want to list down all the dates between those dates, then you can use this approach instead of that one. So this one is simpler in case you do not want that advanced capabilities. Coming to the second DAX, which is CalendarAuto. So I'm going to delete this table and I'm going to tell you why I'm deleting this table. Okay, I'm going to delete this from model. So what CalendarAuto does is it's kind of a intelligent feature or intelligent DAX within Power BI, which detects the existing dates within your model. So right now in my model, if you consider this as a model, although we do not have any additional tables here, but if you consider this as a model, this table has a date column which has dates from 1st January till 5th January 2023. Okay. What CalendarAuto will do is it will detect the dates that are existing in your model, right? And create a range of dates which includes those dates. Okay. And the dates that it creates will be covering an entire year from Jan to December. So let me show you how. Okay. Let me just create a table once again. So I'm going to go to my modeling tab and I'm going to click on new table and I'm going to write CalendarAuto. And I'm not going to supply any parameter here. You can just close the brackets and press enter. Okay. It has created a table. And if I go to my table and format it to a date format and see the results, I've got every date starting from 1st of January 2023 till 31st of December 2023. That is because CalendarAuto generates a list of dates which covers an entire year, but it ensures that it covers the dates which were present in my model. Okay. So let's just test this theory out. Okay. I'll go to my transform data section and within transform data, I'm going to add a new step to replace 1st of January 2023 to 1st of January 2022. Let's go to my data view. And if you see, my CalendarAuto function automatically detected that my first date, the data which my model contains, is starting from 1st of January 2022. So that's why it included 2022 in here, right? It started from 1st of January 2022 and ended till 2023 31st December because my end date falls in 2023. So that's why it has included that year as well. We're going to see a couple of more date time DAX functions which we can use in our daily reporting or analysis purpose. Now, the three DAX that we're going to discuss today are date, DateDiff, and DateValue. Okay. And I'm going to show you how each one of them can be used in certain scenarios with examples. So we're going to start with date. Okay. So to give you a simple idea, what date does is it returns the specified date in a date time format. Okay. So let's see this with an example. I'm going to create a new measure here. And in this measure, I'm going to write date. Okay. And it's asking for three parameters: year, month, and day. So I'm going to supply it with that exact thing. So 2023 year, month, let's say Feb, and day 15. Okay. Now it has created a measure for me with this exact date. Okay. So I'm going to drag this measure onto my canvas and I'm going to drag it into a card. I'm going to format it into a date format. Now if you see, showing me the results as 15 Feb 2023. So what it did was it converted the numbers that I provided for each parameter and converted it into a date. But now when you think about it, how can this be useful? Because it's just a simple static date that you've created, right? So this can be useful when you use it in combination with a different column. Okay, so let's see that with an example. I'm going to go to my data view, and instead of creating a measure now, I'm going to create a new column. Okay, so new column, and within this new column, I'm going to use that same function, but now I'm going to use that date function alongside the date column that I have in this table. Now the requirement here is I want the date to have the same year as this date column. I want the month to have the same month as this date column, but the day should always be the first day. Okay, so I'm going to do is date year. For in the year parameter, I'm going to simply write year. Year is another function that you can use, and within that I'm going to use this pizza sales date column. Okay, in the month parameter, again I'm going to use a function called month, and within that month function I'm going to use this same pizza sales date column. And then day parameter, I'm just going to say 1. Okay, because I want the first of every date that I have in this column, and I'm going to press enter. So, and I'm going to format this into a date again. So if you see, what I've done is I've successfully created a dynamic column which will always give me first of the month of whatever date you have in this column. So depending on the year and the month that it has, it will always use that year and month, but along with that is gonna change the date to first. Cool, right? Coming to the second DAX, DateDiff. Okay, now I'm gonna create another column here, new column. Okay, now what DateDiff does is it returns the number of interval boundaries between two dates. Basically, it returns the difference between two dates, and it also has the option to take a interval parameter. Okay, so I'm going to show you how. So in this, what I want is I want to calculate the difference between these two dates. Okay, so I'm going to use DateDiff. The first date is the starting point. So I'm going to use this column. So pizza sales column. The second parameter is the end date. So we're going to use the date column here. So pizza sales date column. And the interval, now you can provide whether you want the interval to be in days, hours, or minutes, right? Or even months, quarters, seconds, year as well, right? So in this case, let's take it in hours because the difference between these dates are not that great. So I'm going to use hours here and press enter. Now, if you see, I know that these two dates are the same. So 0 hours difference. But if you calculate the difference between these two dates, it's exactly 24 hours apart. And similarly, we have the respective hours for each date calculating the difference. I can also change this to day to check how many days difference is there between those two dates, and it's showing me the correct results here, right? All right, perfect. So now coming to the third and the final DAX, which is DateValue. Now what DateValue does is it converts a date in the form of text to a date in date time format. Now you might be thinking that we can do this even by using the date function that we learned just before this. So let's understand with a different data set here. So I've imported a small data set which has 3 columns in it: day, month, and year. Okay, and each one of them is in a different format. So first one is a whole number, second one is a text, third one is again a whole number. Okay, now if I try to use the date DAX here, so let me just create a new column and I'm going to use date and supply the year as in the parameters. The first parameter is year, obviously, so I'm going to supply it with year. Second parameter is month, I'm going to supply it as month, and third parameter is day. And if I try to create this, it will give me an error because date function cannot convert this text into a integer automatically. Okay. So instead what we'll do is we'll use the DateValue function. And for the date text, we need to first ensure that all the texts are compiled together. So to compile these three columns together, we will use the concatenate operator, which is ampersand. Okay. So this is how we will concatenate all three columns. So to create a date kind of text, what we'll do is we'll use the first column as day. So sheet1.day and ampersand sign and a forward slash, okay, similar to what we have in dates. Then again an ampersand sign, and we're going to use the month, again an ampersand sign, in double quotes forward slash ampersand, and then we're going to use final column year, okay, and press enter. Now if you see, this text has been automatically converted into a date column now. So we can now consider this as a date and format it accordingly. So this is going to be the last video within the date time DAXs that we're going to cover. Apart from the DAX that we've already covered, there are many other DAX within datetime function, and feel free to check them out by going to the link in the description, which will take you to the Microsoft website where you can view all those DAXs. And we will not be covering those remaining DAXs within this video or any future video, because I believe that those DAXs are pretty straightforward and you can follow them just by having a look at it. Since that's out of the way, let's jump into today's topic. And the first DAX that we're going to cover today is something which is simple enough, but this is something that we often use to make our formulas or make our DAXs dynamic. There are two DAXs that we use in this. First one is called now. Okay, so let me just create a new column so that you can see what's happening. Instead of a measure, I'm going to create a column. And first one is now. What this DAX does is it does not take any parameter whatsoever. You can just enter now and close the brackets. And when you press enter, it will give you the current date and time which is there in your system. Now, how does that help? When you create a measure or when you want a column or a formula to be dynamic enough so that it gets updated according to the each day of the calendar, then you might want to use now. And something similar is the second DAX that we're going to cover is today. Okay. So what today does is it, instead of giving you a date time, it gives you a date, the current date. Okay. So again, today, and also this does not take any parameters. You just open the brackets and close the brackets and you press enter. And now it is giving the current date. You are saying date time because this column is formatted as date time. So if I just format it back to date, you will just see the date. So it's showing you the current date as per your system. Coming to the third DAX. So you might have seen a DAX that I used in the last video, which was year and then a month DAX. Okay, where we provided that with a date and it extracted the year out of it and then it extracted the month out of it. Similar to that DAX, there is another DAX which I thought we should cover because we already covered year and month. The DAX is called day. All you have to do is just write day and provide it with a date. So we're going to use this pizza sales date column. And what it does is it extracts the day from the date. Okay. So the first, second and third like this, right? It extracted the day out of the entire date. Now the fourth DAX that we're going to cover today is called Edate. So what this does is it returns a date which is a number of months before or after the start date. Okay, so I'll show you with an example. So I'm going to use the same pizza sales date column, and in the months parameter, I'm going to write 2. So what it will give us is it will use the same date here and it will add 2 months to it. In Edate, when you give a positive number, it means to add that many months. However, if you give a negative number, let's say -1, it minus the number of months from the current date. Okay, so in this case, when I said -1, it gave us December, 1st of December. So it did not change any day or year. It just simply minused 1 month from the current date and then gave us the final output. DAX number 5, EOMonth. Now what this does is, it's pretty interesting. It gives you the last date of the provided date. So let's say you want from this date, so pizza date, you want the last day of whatever date that we have in this column. Okay, so we know that last day should come as 31st January, right? So I'm going to write 0 because I don't want to add any month to it. I just want to calculate the last day of the current month that is there in that column. So I'm going to press enter and it is giving me 31st January. If I gave it a number, let's say 1, what it will do is it will add 1 month to the existing date and then calculate the last day. Okay. So if you see, now it's giving me 28th Feb. Similar to Edate, we can also add negative numbers to it. So -2, let's say, and this will give me 30th November. Now in EOMonth, there's an interesting pro tip. Instead of the last day of the month, you want the first day of the month, right? So in that case, what you will do is, let's say I want first day of whatever date I have, I want first day of the next month. What I can do is 0, which will take it to 31st January, and then say +1, which will give me 1st of Feb. 6th DAX, Networkdays. So what Networkdays does is, it gives us the number of working days within your supplied dates. Okay. And you have an option to remove weekends as well from this, as well as holidays. Okay. So the starting date for me is 25th of November 2022. Okay. I'm going to enter it within a double quote. So I'm making this a static date. The end date is the date that I have here, pizza date column. Now in the weekend parameter, I'm going to write 1. So what 1 means is, it's considering Saturday and Sunday as a weekend. Okay. But there are other options as well. I'll paste a screenshot on the screen somewhere. You can pause the video and check out the other options that are available if in case you want a different weekend. So let's say your company or your organization have a different weekend structure. Let's say you have holidays on Friday and Saturday instead of Saturday and Sunday. So you can use that as well. For now, I'm going to use 1 only. Okay. Because I want to consider Saturday, Sunday as the weekend. And in the last parameter, which is holidays, what you can do is you can supply it with a list of holidays that you have in your organization. So what you need to do is you can create a new table, a separate table, which has a couple of dates in it. Okay. And you can consider those dates as your holidays, and this formula would automatically ignore those dates while calculating working days. So for the final parameter for holiday, I've imported a table which is called holidays, and I just have a simple column in that table with a couple of dates, which will represent the number of holidays that I have in a particular year. Okay. So for now, I'm going to use that table itself. So holidays. Okay. And close. It's calculating number of working days using the starting date that I provided and the end date. Okay. You see a negative number here is because the end date that I supplied here for these 3 row items is smaller than the start date that I provided, which was 25th of November 2022, right? So that's why you're seeing a negative number. But otherwise, what it did was it ignored Saturday and Sunday because I said 1, and calculated the working days considering the list of holidays that I have in this table. Okay. So we have a couple of holidays in this table. So it considered that and calculated the final network days. Last DAX for today is Weekday. And what Weekday does is it returns a number which represents a day in a week. Okay. So let me give you an example. Pizza sales date. And there are 3 options to it. 1, 2 and 3. 1 means your week starts from Sunday and ends on a Saturday. So Sunday being 1 and Monday being 2 and so on and so forth. If you choose 2 here, that would mean your week starts on a Monday and ends on a Sunday, Monday being 1. And 3 means your week starts on a Monday and ends on a Sunday, but the Monday will be counted as 0. So the numbering would start from 0 and then 0 for Monday, 1 for Tuesday, and so on and so forth. So I'm going to choose 1 where my week starts from Sunday. So it has given me a number which represents each day of a week. So I know that 2nd January was a Monday. So that's why it's showing me 2. Today we're going to start with the aggregate functions that we have within DAX. Okay, and there are many aggregate functions that are available, and I'll place a link in the description where you can access the full list of those functions. But today we're going to cover the most important ones that you will ever need while working with aggregate functions. Okay. Now, starting with the most basic ones that we already know and use in multiple scenarios are sum, count, average, and count A. Okay, so we're gonna just quickly see how that works because I just wanted to cover the basics. Although you might already know these functions, so feel free to skip ahead in case you already know them. But just for the beginners, I'm gonna just cover them quickly. Okay, so when you talk about sum, and I'm gonna create a measure to showcase all the aggregate functions here. I'm using the same dataset that we used last time, the pizza dataset, right? So what I'll do is I'll just insert a new measure, and within this measure, I'm going to first write the sum function. Okay, so sum simply means that in case you want to sum an entire column, you can just apply a sum function, and let's say I want to sum the entire sales. So you just enter it like this, and that is it. It will give you a sum of the entire sales column, and I'm going to drag this into a card so that you know what's happening. Okay, now remember there are other options to apply filters within this measure, but we will not be covering those in this video because we just want to cover the basics first and then get into those mashup functions where we club together multiple functions together to create amazing results, right? So we're going to get to that in future videos, but for now let's try to focus on the basics. Now you understood how sum works. Similarly, this is how count works. So you can just write count. Let's say you want to count the number of pizza names that you have in your data. So it will just give you a count. Okay. Basically, it's counting the rows that are there. The third function is average. So let's say you want the average sales that were there for all the rows that we have. So you can just apply average. So it will give you the average results. And then we have count A, where we can just count number of values in a column which are not blank. Okay, so I can use any column here, pizza code, let's say, for example, and it will give me a count. All right, now let's jump into the exciting stuff. All right, there are a set of functions within DAX, especially within aggregate functions, which has an X at the end of it. Now here is a list: sum X, count X, count AX, average X, min X, max X, and product X. Okay. Now, do you understand what that X stands for? Basically, X stands for expression. And what these set of functions does is it calculates a certain expression at row level and then apply the final function at the end. So let me give you an example. So let's say in this data, you want to first multiply your sales and price USD together, and then the output of that multiplication should be summed up for each and every row. So whatever output that you receive, all those outputs should be summed up at the end. Now there are two ways to do it. First one is to create a calculated column, and in that calculated column, you need to apply this multiplication, and at the end you can apply a sum function, right, in a measure. But that's a longer approach. A better way to do it is to apply sum X. Let me just quickly apply that function and show you how it's done. So let's say I'm going to write sum X. Okay, and what I want to do is, first of all, refer a table. In this case, it's pizza sales, and the expression that I want to give. So expression is simply a formula or some kind of logic that we want to implement within this sum X function. Okay, so let's say I want to use price USD column, and I want to multiply that with sales. Okay, and then close the bracket. It has given me 14K. So let's see if the result that we got is correct or not. So what I'm gonna do is I'm gonna create a new column here. In a new column, I'm gonna multiply the price USD column with sales column. Okay. So I've got this result column, right? Now what I will do is, in a new measure, let me create a new measure here. I'm gonna sum my column, okay, the new column that we created. And I'm gonna drag this again into a card. And if you see, the results are the same, right? But while applying this method, we did an extra step of creating a new column, which obviously increased your file size. And then you applied another sum function to get this result. But in SumX, we simply applied SumX and got that result. Now, let me give you another example, okay? Instead of SumX, let's apply AverageX. So again, the table name is pizza sales, and I want to subtract sales figure with unsold figures and then get an average of that entire thing. What this function is doing is, first of all, it's subtracting unsold value from the sales, and then with that result for each row item, it is calculating an average. Okay, so I'm going to create one more column here, and within this column, I'm going to say sales minus unsold. Okay, and this column 2, I'm going to write another measure here. Using this measure, I'm going to say average column 2. As you see, the results are the same, but the first approach is much better, right? So I hope you understood the expression aggregation functions. There are a list of functions that you can use, including minimum, maximum, product, average, count, etc. So you can just go through them, try it out on your own. The concept remains the same. It will calculate whatever expression you provide for each row item and then apply the final function that you gave it. I mean, whether it's an average, count, sum, or whatever it is. Okay. All right. Perfect. Now coming to the final part of this video, which is distinct values. Okay. Now it has 3 main functions to it. 2 of them would be covered in a measure, and the final one we will cover it in a table. Okay. So we'll see how it's done. So first one is distinct count. Okay. So let's say you want the distinct count of pizza names here. Okay. So what you can do is just write distinct count and choose pizza name column, and it will give you a count of 6. But I know for a fact that total pizzas that I have, the type of pizzas that I have, are 5. It is giving me 6 because there is a blank row in this data set and it's counting blank as well. Okay. So in order to avoid that, you use another function which is called distinct count no blank. Okay. So distinct count no blank, again pizza name, and this time the results would be 5. Cool. All right. Perfect. And the final function in this is distinct. So what distinct does is it returns a table with one column with the distinct value of whatever column you require. Okay. So what we'll do is we'll go to modeling tab and click on this new table. And within this new table, I'm going to write distinct and I'm going to use pizza name column. Okay. So what this DAX does is it creates a table for you. You remember a couple of videos back, we saw 2 DAXs within the datetime function, which can create a table. This is a function within aggregate family, which can create a table. If I go to the data view, this is the new table that we created. And if you see, it has given me the table with distinct values in it. Now there is a blank value here because as per Power BI, blank is also a separate value. So that's why it's considering that as a distinct value. You can apply additional filters onto this table in case you want to remove that blank value. Okay. Today we're going to discuss a very important topic, which is logical functions. And trust me, while doing any type of analysis on your data, logical functions are very essential and it becomes a backbone for many complex calculations that you do. Okay, so it's important for you to understand this particular function. So we're going to discuss today 5 basic logical functions today. And these are IfError, and, or, and then switch. Now out of this 5, We have already discussed switch in detail, so I'm not going to cover that in this video. You can check out the Excel switch function video that I made a while back. Links will be in the description, which will explain the switch function to you. So the concepts are the same in both Excel Power Pivot and Power BI. So whatever applies there goes here as well. Okay. So now we're going to jump into our first function for logical functions, which is if. Now what if does is, if checks a condition and returns one value when true, otherwise it returns a second value. Okay. So this is how it goes. So I'm going to create a new column here. Now the requirement here is, if a particular pizza sales is above 100, then I want to mark that pizza sales as a top seller. Otherwise, I want to tag it as an average seller. Okay. So for that, I'm going to use this new column and I'm going to say if sales column, right, which we wanted to use as a logical test, is greater than 100, then the result should be top seller, else it should be an average seller. So as you see, I've given it 3 parameters. First one is obviously the logical test that we're doing, whether the pizza sales column is greater than 100 or not. So if this statement is true, we're going to use this string, which is top seller. And if it is not true, then we're going to use this string, which is average seller. So we have used these 3 parameters. And if we press enter, every sales item, which is greater than 100, it has automatically marked this as top seller. Now let's look at second function that we will cover here is IfError. Okay. So this will be helpful when you want to specifically identify if a particular value or a particular row has some kind of error in it or not, and then accordingly assign a certain value to it. So to do that, I'm going to insert a new column here, and to create an error manually here, because I don't have any error in this data set, so I'm going to create a error manually. What we'll do is we'll simply divide the sales value by 0. Okay, which will give us an infinity or division error. Okay. Now what we'll do is we'll create another column and we'll say if error column 2, right, which is the first parameter. So we have to define the value that we want to check, and if that value has any error, I want to mark it as, let's say, 0. Okay. As you see, it has marked all error values as 0 and left that blank value because it did not have any errors in it. Now comes the third function, which is AND. Now there are 2 ways to write an AND function. You can write it like this, AND, okay, or you can write it like this, ampersand sign twice. Okay, this signifies the same thing. But a major difference between both of them is when you write an AND function like this, you will only be able to give it 2 logical conditions here. Okay, not more than 2. But when you use a double ampersand sign, you can use as many logical conditions as you want. Okay, so I'll show you examples of each. Okay, so the first requirement that we have is I want to simply check if we have pizza name as deluxe, and second condition is category equal to non-veg. So if both of these conditions are met, because AND means whatever logical conditions that you provide, all conditions should be met, then it will give you a true value. Okay, so if both of them are true, it will give me a true like this here, but anywhere else it will give me a false. Similarly, I'm going to get back to the AND condition again when we are using the ampersand sign, but let's cover the OR function first. So OR is similar to AND. Again, when you write it like this, you only have 2 options, 2 logical options. But another way to write OR is a double pipe sign, and we're going to get to that in a while. When you're using a normal OR, let's say the condition is you want to see if pizza name is equal to double cheese or category is equal to veg. In both these cases, I want it to have a true value, else false. So as you see, it has given me the correct values here. If it was a double cheese or if it was a veg, it has given me true values. Anywhere else, it has given me false values. Now let's see an example of using AND and OR inside an if condition, okay, which is again very powerful. So we are now mashing up 2 functions together, right? So what we do is if, now the logical test is I'm going to say AND price USD is greater than 10 and column value, which we created earlier, is equal to top seller, bracket close. Then if both of these conditions are met, because we are using AND, it would simply imply that both these conditions should be met. If both of them are met and it is true, then in that case, I want it to mark it as star. Else, I want to mark it as budget and close the bracket and press enter. So as you see now, it has checked all the rows, all the conditions, and accordingly applied the values that I've given it. Okay. Now let's see an example where instead of using an AND, we can use a double ampersand sign. Okay. And you will observe that using a double ampersand is much more readable when you look at a formula. Condition goes like this. If pizza sales is greater than, and this time I'm going to use equal to 10, and column value is equal to top seller, then, okay, I'm going to remove this bracket because I don't want this. So I'm going to check if both these conditions are true, then assign it a star, else mark it as budget. So if you see, it has applied that. Now the good thing about ampersand sign is I can always add another condition here, which was not possible while using the normal AND function. So I'm going to add a third condition which says and pizza sales unsold column is less than 10. So if you see, it has accommodated that third criteria as well. Similarly, like ampersand sign, we can use the OR function using the pipe sign here. Because we're using OR, it will see if any one of the condition is true, then it will mark it as a star, else it will mark it as a budget. So with this, I think all of them are stars, right? So again, depending on the condition, you can choose to have if or condition, if and condition, and then also club if and or together by separating them out with brackets. So like for example, I can do it like this is equal to top seller and pizza sales unsold is less than 10. Okay, I can do it like this as well. Today we're going to look at a couple of functions which are in the text function category. Now, as per me, the list of text function that we are going to cover today would be more than enough for you to master this particular category of functions. But in case you want to explore more text functions, then I'll place a link in the description. You can go to that link and check out the other functions which are available and explore them. All right. So without wasting any time, let's just quickly jump into the text functions. So the first one that we're going to cover today is upper and lower. So I'm going to just create a new column like we usually do. Okay. And what upper and lower does is it changes the text into an uppercase text or a lowercase text. Okay. So you just write upper, and let's say I want to convert all my pizza names into an uppercase. You just enter it like this, and instantly all of your values will be converted to uppercase. Similarly, you can use lower as well to convert all of them into a lowercase. Unfortunately, proper case is not something that we have in DAX. So in case you want to convert your text into a proper case, you would have to go to Power Query and convert it from there. Okay. All right. So moving on, the second function that we're going to cover is called concatenate. Basically what this does is it concatenates multiple strings together. Okay. So the way you write it is just say concatenate and then enter your text that you want to concatenate. Let's say I want to concatenate the pizza code and pizza name. Okay. So it will give me the concatenated string. But one thing to notice here is when you're using concatenate function by writing concatenate, it only give you option to concatenate two text, right? It's similar kind of limitation that we had or we saw in the logical functions when we used and or. So similar to that, we can use concatenate in a different way by using ampersand sign, and I'll show you how. So all you have to do is mention your column name. So pizza code, okay, and then you write an ampersand sign, and then you write pizza name, and let's say I want to concatenate category as well, so I'm going to use that as well. Okay, so if you see now I can concatenate more than two strings if I'm using the ampersand option. Now obviously reading the text like this does not make sense. You would have to give some space in between. So in order to do that, you just write it like this. So what I've done is I've added another ampersand sign in between and added a space to it. And let's say in this I want an hyphen sign, and here I want a space. So when I enter this, as you see, it has given me the text that I wanted. All right. The third function that we're going to cover is len. What this function does is it gives you the length of characters or the number of characters that you have in your particular string. So let's say I want to identify the number of characters that I have in the pizza name column. So I'll just write len pizza name and enter. So it has given me the length of each string that are there at each row. Now comes an interesting function, which is left, right, and mid. So, and this is something that we usually use a lot, even when we are using Excel. And you must observe that most of these functions that we are discussing today are exactly the same in Excel as well. So if you know these functions in Excel, you would not have any problem anyhow. And if you learn it here, you can apply the same thing in Excel as well. Okay, so let's say left. What this does is it returns a specified number of characters from the start of a string starting from left. Okay, so how does that work is, let's say I want the first 4 characters from the pizza name column, okay, starting from left. So what I'll do is left text would be pizza name, and number of characters that I want is 4, and press enter. So what it will do is it will count 4 characters from the left here and give me the output, right? Similarly, I can use the right string, enter right, and let's just say I want 3 characters from the right, and as you see, it has given me the required characters from the right hand side of my column. Now then we have a function called mid. So what mid does is it returns a string of characters from the middle of a text string. So we would have to give a starting point and the length of a particular string that you want from that particular column. So let's say again pizza name, okay, and I want, let's say from the second position, okay, so I will write 2, I want 3 characters, okay. So starting from the second position, I want 3 characters. So if you see, it has given me that exact thing. So starting from the second, which was E in this first row, and it has taken 3 characters starting from the second position, okay. So it has given me what I wanted from the mid. So mid is bit more flexible in case you want to extract certain number of characters from an entire string. Okay, so next is replace function. So what replace does is it replaces a part of a text string with a different text string, okay. So let's say I want to replace the first 4 letters of whatever string I have with the word city, okay. So what I'll do is as an old text, I'll give pizza name, okay. Starting position, I want to keep it as 1 because I want from the start first position, I want to replace whatever there is, and the number of characters I want to replace is 4, and the new text that I want to place here is city, okay. So basically what I want to do is replace the first 4 characters with the word city, okay. So I'm going to press enter, and as you see, it has replaced the first 4 characters. We can also choose to, let's say instead of 4 characters, I want to replace 8 characters and replace it with city, okay. So if you see, because in the first row, we did not have 8 characters in this entire string, it replaced everything, okay. And it just pasted city there, removing everything from here. Wherever we had 8 characters or 8 or more characters, it simply removed the first 8 characters and then put in a city there, and then the remaining characters. Like here in the double cheese row, it has removed 8 characters from the beginning and then put city there. Now the next function is substitute. Now what it does is it replaces an existing text with a new text in a text string, okay. Now you would ask, what is the difference between replace and substitute, right? The main difference here is substitute can find a particular character in your entire string and then replace that accordingly. So here is an example. So in this entire string, wherever it finds alphabet O and U, I want to replace that with A and N, alphabet A and N. I'm going to give the text as the column name, which is pizza name. The old text that I want to search is OU, okay? And the new text that I want to give is AN. And mind you, this is case sensitive. So if I capitalize this, this will not replace this OU here, okay? Because this is in small letters. And the instance number, this is an additional parameter that we can give. Instance number simply means when it searches from the left. So it is actually searching the entire string from left. And the first instance it finds, it's asking whether you want to replace that or you want to replace some other instance that it finds. So first instance of the same thing, second instance, like that, right? So right now I'm going to replace the first instance and enter, okay? As you see, it has changed OU here because it was the first instance. Similarly, let's say I want to replace every E with an A. Now I want to replace the second instance now. Observe this. In Deluxe, I have E at the second position and then E at the last position, right? And I've said replace E with A only for the second instance. And I'm going to press enter. Now, if you see in the result, it has not replaced the first instance. Instead, it has replaced the second instance. Now, if I write third instance, it will not replace anything for Deluxe because it did not find any third instance. But for double cheese, it did find third instance. So I hope you understood how this works. Now the last and the final function that we're going to see is search. You basically give it a text that you want to find. So I want to find, let's say, X in pizza name column. And the starting position that I want to check is, I'm going to keep it as 1 because I want to start searching from the first position itself. And not found value that I want to see is if it did not find any text with that particular character, I want to enter as 0. So what this function does is it gives you a position of the character or the text that it found in that entire string. So this 5 simply means it found X on the 5th position in the string. So starting from the left, if you count 5, 1, 2, 3, 4 and 5, it found X on the 5th position, right? And the 0 means because we've entered 0 for no value, it simply means that it did not find X anywhere in this particular string. The DAX that we're going to cover today is going to be very important for you to understand, and this will be used again and again in multiple scenarios whenever you start working with data. Okay, and the DAX that I'm talking about is called Calculate, and we will also see how we can use Calculate with a specific DAX function called all, and in what scenarios we can club both of them together to get desired results. Let's go. I have this dataset here. This is the same dataset that we used in our last video, which contains a list of names of a couple of students and the subjects that they are studying and the score that they attain in one of their semesters. Also, I have another table with the same list of students that I had in semester 1 score table with the scores that they attained in semester 2. And for ease of use, I have merged both the tables together so that semester 1 score and semester 2 score are in the same table like this. I'm going to rename this as master table. Now, before we get into the topic of how to use calculate and all together, it's important to understand what is calculate function. Now, although I have covered this topic previously in one of my videos, but just in case you have not seen that video, I'm going to give you a quick recap of what calculate function is all about. So in essence, what calculate function does is it evaluates an expression utilizing a filter criteria that you provide. Let me give you an example. So let's say you want to know the sum of score acquired by student B in both the semesters. Okay. So for do that, I'm going to insert a new measure here, score by B, and I'm going to write calculate sum of master semester 1 score plus sum of master semester 2 score. In the filter parameter, I'm going to write name is equal to B. Now let me drag this new measure into the canvas to see what's happening. I'm going to drag it into a card. So now I know that student B has acquired 390 across both the semesters. Also, one more important thing to keep in mind. Right now, our filter parameter is not complex. It's simply stating a particular table column name and using an equal operator to define what kind of filter we require. But just in case you want to use multiple filters, you can do that by applying a comma here and then adding your second or third filter, whatever it is, right? And also, one more thing to note is if you want to use a measure inside your filter, you cannot directly apply that measure here. In that case, you will have to use the filter function here and then use the measure that you want to use. We'll see an example of that as well. So I'm going to create a new measure and it will be a simple measure where I'm going to assign it a value, maths. Now, let's say I tweak the requirement a little bit. I want to see the total score attained by B in subject maths. Okay, so I'm going to use a second filter criteria and this time I'll try to use a new measure that I created. Now if I press enter, it will give me an error. That is because in this filter parameter, I cannot directly use a measure. In case I want to use a measure, I would have to encapsulate that inside a filter function. So table would be master and the filter expression would be, this one is the first expression. And if you remember, we learned about operators. So double ampersand, this signifies an AND condition. So I'm going to say filter master table name is equal to B and I've clubbed it with another condition, subject is equal to measure. Measure is nothing but the text that we entered into that measure, which was maths. Now if you see, it has given me the score attained by B for maths in both the semesters. Now I'm going to just remove this filter here and I'm going to just use master table name is equal to B. Now since you got an understanding how Calculate works, let's understand in which scenario do we require to use all alongside Calculate. So I'm going to drag in another visual and this time a matrix, and here I'm going to create another measure, or let's say we can utilize this measure only, and I'm going to add both semester 1 and semester 2 scores together. Sum of sem 1 score plus sum of sem 2 score. Okay, and I'm going to name it as total score, and then I'm going to drag it here as well and then remove semester 1 and semester 2 score because I don't require it anymore. Now let's say you want to identify how much percentage does each student have in comparison to the grand total that we have here. Now for this scenario, you might think that we can straight away use percentage of grand total from here, right? But if we use that, this will be creating an implicit measure. If you remember, we covered what is the difference between implicit and explicit measure in my previous videos, right? So you understand that implicit measure are not that flexible to use. So it's always better to have an explicit measure so that you can drill down into multiple columns and multiple values without any difficulty. So for that to happen, there are two things that are required. First one, I would need a total count somewhere, as in a count of this 1418 somewhere, so that I can divide 327 with that grand total to get my percentage. Because this total exists separately, you cannot refer to this total anywhere because this is something that is created by Power BI as an implicit measure and you would not be able to use this in your calculation, right? So to use this in your explicit measure, create a new measure. I'm going to call it grand total. I'm going to write calculate and then I'm going to use this new measure that we created, which was total score. And in the filter criteria, we're going to use all, okay? And what all does is it removes any other filter context that is already there on that table. So right now in this table, the values are splitted on the basis of the name column, right? So each student has their own particular row item and we do not want that. So that's why we're going to write all, and inside all, I'm going to use this table name, which was master table. That's it. Now I'm going to use this grand total inside this table so that you see what's happening. So as you see now in the grand total, I have this 1418, but our work is not done. I'm going to change the name of this measure, grand total percentage, and I'm going to use total score divided by the grand total. Now if I apply and convert this into a percentage, you will see out of the total marks these students scored, A has 23% of the total, and B has 28%, C has 23%, and D has 26%. Cool, right? So this is how you can club, calculate, and all together to supersede any particular filter or grouping that we already applied on a particular table or a visualization. So today we're going to look at another important and interesting DAX function which lets you utilize the relationships that you build within your data model and utilize that relationship within your DAX function. The DAX that we're talking about today is called Related. And if you remember a couple of videos back, we created an entire data model. I showed you how to create a data model, right? So we're going to use that same example here. As you see in my data model section, I have a couple of tables which are connected together to create my entire data model universe. Okay. Now I'm going to show you how we can use the related DAX function and utilize this data model and the relationships that we built in that data model to get values. Okay. So this is how the related function works. So I'm going to insert a new column here. In this new column, I'm going to write related, and this is how the syntax for related goes. So you just simply write related and you give it a column name, as simple as that. But if you notice, right now I am creating this column in the pizza sales table. And when I wrote related, it is giving me all the columns from other dimension tables as well. That is because we already established a relationship between all those tables, and I can refer to any column from that another table using the related DAX function. Okay, so this is how. So let's say I want to get pizza name from the pizza code dimension table. This is just a basic how related function works. Related works on a row level basis, right? But applying related like this goes against everything that we have seen so far, as in terms of data normalization, right? Because it is simply creating a redundant data in my table, which I do not specifically require, because if I've created a relationship, you can simply drag and drop these columns from the other table into any reporting layout or visualization you want. So why to have this here, right? But because a related function works on a row level basis, you can utilize this related function in a more efficient way by clubbing it with another DAX function. Okay. So let me give you an example. So I'm going to say I have to create a new column, and in that new column, I have to check if a particular pizza name is deluxe or not. If it is, then give the value of 1, else give the value of 2. Okay. So for that to happen, obviously I need the if function, but when it comes to the logical test that we need to build, because my name of the pizza is not existing in this current table and it is somewhere existing in another table which is related to this table, I can use the related function. So here goes. So I've written if and then related, and I'm going to give the name, column name as pizza name. This is what I need. And I'll say equal to deluxe. Then if my logical test turns out to be true, because it works on a row level basis, it will go one row at a time and it will check if it is deluxe or not. If it is deluxe, then I need 1, else I need 2, and press enter. So as you see, now this makes sense, right? Now I've created a new information column here utilizing my if function, and I've clubbed related DAX function with if to create something new. One more interesting use case for related function is when you want it to return a table. Okay, so let's do that. I'm going to go to that table tools here at the top, and I'm going to create a new table. Okay, and in this new table, I'm going to write a DAX which is called filter. Okay, now what filter does is it returns a table with certain filters that you apply. Okay, so I need it to return pizza sales table, the entire table, and the expression being related pizza name equal to farmhouse. So what it did was it filtered out the data from pizza sales table using the filter that we provided. The filter parameter was simply saying pizza name should be farmhouse. But if you remember, pizza sales table does not have pizza name column. So we cannot directly apply pizza name equal to farmhouse, right? That would not work. So instead, you would have to use a related DAX within this. So we have clubbed related with filter to get this result. Also, you can utilize related inside other DAX functions like SumX or calculate, and we'll see examples of those in future videos. But this is how you should be using related. Instead of simply calling it inside a table to create a new column, use it in combination with other DAX functions to create interesting output so that you don't create a redundant data and it does not impact your data normalization as well, right? Today we're going to cover a specific function in DAX which is called RelatedTable. For covering today's topic, I have created a dummy data, and that dummy data has 4 tables in it. This data contains particular information about students of a particular school. Now, the first table contains the date of birth for a couple of students with their names. The second table contains the roll number that they have in their classes with their names. The third table is the score that they attained for English, Maths and Science in semester 1, and the second table is again the score that they attained in English, Maths and Science in semester 2. So the main topic for today's discussion is the difference between related function and related table function. To help you understand in a better manner, I'll show you examples of each differences with couple of scenarios. And the first difference that is there between both the function is the type of data that it returns. Related function returns a scalar value. So when you apply a related function, it gives you a single value. Okay. However, related table, as a name implies, it returns a table instead of a single value. So let's just quickly see how it impacts us. Okay. So before doing that, I'm going to go to my modeling section here and I'm going to connect these two tables. So I've connected these two tables, the date of birth table and the roll number table. Okay. So that we can write our related functions now. So let me go to this table, date of birth table. I'm going to insert a new column. I'm going to write related and I'm going to fetch roll number from the other table. Now, since my data set is small, I'm not worrying too much about data normalization. So that's why I'm fetching the column directly from that table. As you see, because related function returns a scalar value, I have a couple of values here. Now let's see what happens if I use related table here instead of related. Now related table does not give you an option to give a column. Instead, it gives you an option to give a table, right? So that's why I've used roll number here. And when you enter this function here, you will get an error. That is because since this function returns a table, it cannot be converted into a scalar value. That's why it's giving me an error. So how will you use related table then in that case? In order to use related table, you will encapsulate related table inside a iterative function. Like for example, I can use this in SumX, or I can use this in count rows or something like that, right? So I'm going to use this inside a SumX function. So it has given me the roll number for each student name. Now coming to the second difference, cardinality. If you've seen my previous video, we have written the related function inside the fact table and fetched the information from the dimension table, and not the other way around. That is because related function works only with many-to-one or one-to-one relationships. So I'll give you an example. I'm going to join this semester 1 score with roll number table here. So now I've created a many-to-one relationship here. So many being in the semester table and one being in the roll number table. Now if I try to apply the related function inside this, so I'm going to say related, and I'm going to fetch, let's say, roll number, right? It will give me that result. Okay. Also, if you noticed, we created a relationship between only the roll number table, but it is giving me an option to select the column from the date of birth table as well. And it will give me correct results for that. That is because related function follows the many-to-one relationship as long as the chain extends. So although we created this relationship, but this table has a relationship with date of birth table as well. That's why we are able to fetch information from there. But what happens if I do this other way around? So let's say instead of applying my function inside the semester 1 table, I applied my function in roll number table, and I say related, and in the column name it's not giving me the option to select anything from my fact table or anything from my semester 1 table. Okay, that is because, as I said, the related function works from many to one, not from one to many. Okay, so that's why this will not work. But on the contrary, related table function works either way. So related table can work from one to one, one to many to one, or many to many. Okay, so it can work on all direction, any cardinality. Okay, that's the difference. Now, if I want here, I can use related table. Okay, now I'm gonna get, if you see, I can select semester 1 score. However, selecting a table like this does not make sense because it will again give me an error because it's returning a table I want a scalar value. So I can encapsulate this inside a sumIs function. So it is giving me the total of scores, so clubbing every score together for each student. So let's just see how this will work in a many to one relationship. So right now we just saw how it worked in a one to many, but in a many to one relationship, I can go to my score here, create a new column, and I'm going to write related table, and I'm using roll number here. Although in this scenario, I can use related as well. That will work just fine. Okay. So it has given me the roll numbers for each students, even though we had many records in this table. Now let's see an interesting scenario where related table works on a many to many relationship, which is not possible using the related function. To create a many to many relationship and to make our lives a bit more easier, I'm going to go to transform data and I'm going to create a unique key in these tables. So I'm going to merge these two columns together so that we can create a unique key. Okay. So to merge, you can just go to transform and click on merge columns, and I can choose a delimiter. So I'm just choosing a delimiter here and press OK. It has merged both the columns together. Similarly for semester 2 score as well, I'm going to select both these columns, click on merge column, select a delimiter, and OK. Okay, so now both of my columns have a unique column which we can use to create that relationship. Okay, so I'm going to close and apply. Now in the modeling tab, as you see, the moment we created that key, automatically Power BI detected that relationship and applied that. Okay, so we are good with this. Now I'm going to go back to this table here and I'm going to create a new column, and I'm going to write related table, and the table being semester 2. Okay, and I'm going to use a sumIs function because we need a iterative function to work with a related table function. So I'm not going to write any complicated expression here. I just need the semester 2 score here and enter. So as you see, it has fetched the correct results for me. And if you want to just check, A English is 48, A Maths is 55, A Science is 55. So I'm going to just go to semester score. So 48, 55, 55. So it has fetched the correct results for me. The topic that we're going to discuss today is yet another DAX function, specifically in the relationship functions family. Just like the ones that we covered in previous videos like related and related tables, this one is called Crossfilter. Now I'm going to show you how Crossfilter works and why do we actually require Crossfilter. But before we begin, let's understand the dataset that we're going to use today. It's the same dataset that we used a couple of videos back, which was the pizza sales data. I'm only using 3 tables here so that it's easier for you to understand the Crossfilter functionality in a better manner. The links for the dataset will be in the description below, so you can download that dataset and follow along if you want. The first table in this is a date table, which contains 3 columns, one for date, month and day, right? The second table is again a dimension table, which is a pizza code table, again 3 columns, pizza code, pizza name and category of pizza. And the third table is a fact table containing 3 columns, which has the sales value for each pizza code on a particular date. So without wasting any time, let's just quickly jump into Crossfilter functions. Before we actually write the DAX, it's important to understand why we need Crossfilter. Okay, so for that, I'm going to go to this modeling tab and show you the relationship that I have currently built for these three tables. Now, in the center, you have the fact table, which will have multiple records. For any single category or a single date, we have multiple row items. Then we have dimension tables, namely date and pizza code. Each one of them has unique values in it. So when we connect it, it creates a one-to-many relationship. So from pizza code to pizza sales, pizza code being the one part of it, and pizza sales has many records in it. And you can see that here as well. It says 1 on this and it says star here, right? So which means one-to-many. You might remember from my previous video, when you build a data model, when you create relationship between two tables, this arrow is pretty important. This signifies the type of relation these tables have with each other, whether it's a single directional relationship or a both directional relationship. Now that is important because when you apply filter to a certain table, if it's a single directional relationship, the filter context flows from the one to many, which is indicated by this arrow sign. So wherever this arrow is pointing out, the filter context will flow in that direction. So in this case, it will flow from pizza code to pizza sales. And same goes for the dimension date table. The filter context flows from dimension date table to sales, pizza sales table. Now, why is that important? Now I'm going to go to my data tab view here. So let's say the requirement is I need to create a table where I have date values, and adjacent to that date value, I want sum of sales, which will come from this pizza sales table. And I want another column which will give me the count of unique pizza names sold in each date. I do not need the count of pizza code. I want the count of pizza names, which is existing in this pizza code table. Now, remember, the filter context is flowing from pizza code to pizza sales, not the other way around. Okay. So let's see what happens if we try to create that table as it is. Okay. So I'm going to drag this date column in the reporting view and I'm going to convert it to date. And I'm going to drag this sales from here. Okay. I'm going to convert this to a matrix, and then let me create another measure. Okay. In this pizza code, count rows, pizza code. Okay. From the dimension table. Now let us drag this here. And if you see, the count that it gives me is 5 for each and every item. That is because in the pizza code table, I have 5 types of pizza, right? And it's giving me a straight away count. It's giving me a count of all basically, and not applying any filter context. That is because the filter context is flowing from pizza code to pizza sales and from dimension date to pizza sales. So when I use a dimension from the dimension date table, the filter context flows from this table onto this table, which is the fact table, but stops there. It does not flow through this pizza code table. When we are trying to use a column from this pizza code table, that is why it's not giving me the correct number. But what happens if I double click on this relationship and instead of a single relationship, I make it both? Now if I go back, it is giving me the correct count. So let's check what's happening. I know that in pizza sales table on 1st of January, I have sold 3 types of pizza, namely farmhouse, deluxe and double cheese, which is indicated by this pizza code. Now you might think that in this specific scenario, instead of counting the pizza names, I could have simply counted pizza code from here and that would have solved the problem. And you're right. But I'm trying to explain the scenarios where you would not have that flexibility and you would have to count some other column which does not exist in your main fact table. So in that case, you would have to use either this method where you are making it as both. But the problem with this method is if your data model is complex enough and you do not want to make any changes just to do this one calculation, then you will find a challenge. Because just to do this one calculation, if you're trying to make a cross-filter direction change in your entire data model, that can have weird behaviors in other calculation that you're doing, right? And you do not want that. So I'm going to convert it back to single again. Okay. And I'm going to come back to this reporting view. And in this measure, I'm going to encapsulate this inside the calculate function because cross filter does not work alone on its own. You would need a function something similar to calculate. Okay, so I'm going to write calculate, and in the filter section I'm going to write Crossfilter, and the column that I'm referring to right now is pizza code from dimension and pizza code from pizza sales, because these two are the foreign and primary key which we use to create our relationship. Now in the third parameter here, which is cross filter type, you have 5 options: both, none, one way left filter right, and one way right filter left. Now in this specific scenario, we only need both. So I'm going to write both and close the bracket and press enter. Now, as you see, it has given me the correct number and it has the same result as if I have manually gone here and changed the relationship to both. But as I said, scenarios where your data model is complex and you do not want to manually make any relationship changes here because you do not know what negative impact it could have on other calculation that you're doing, in those scenarios, you can use this cross filter function. So with that, we have finally concluded our DAX masterclass video. In case you found this video helpful, then please consider subscribing to the channel because it takes a lot of effort to create such videos for you, and I need your support and motivation to help this channel reach its full potential. Now in case you have any suggestions for future videos, do let me know in the comment section. I'll be happy to take that up next time. And as always, thank you so much for watching. I will see you in the next one.